Yeah, my name is Enoch, and then I was also part of the cartography master program, and my colleagues just finished presenting. My topic was creation of an automated workflow for the production of a printed map, basically from open data and OpenStreetMap. The question will be that why printed maps? Of course, printed maps will continue to be there. We use maps on our phones these days a lot, but I have a very quite interest for printed maps, which led to the motivation. But generally, we can say map production, it's an essential part of cartography. And when we talk about map production, it's bringing together all the processes, and then in the end, we have a map. But in order to make this an automated workflow, then we are putting together a machine processes that come together in the end to give us a compilation. And then we also have an output, which is a map at the end. My thesis topic was motivated by OpenStreetMap. Of course, I contribute to OpenStreetMap, and I'm one of the few contributors from Ghana, where I'm from. And another motivation was the way OpenStreetMap has found its way into national mapping agencies for map productions. And one interesting case here is from the BKG, which uses OpenStreetMap in some part of the production of what is known as the top Open Plus, which is a map, the Europe here that I think covers the whole world sometimes, that you can use, and it's a service provided by the BKG. And principles of free and open source software and free software in general were the motivation. So in the starting, the research objectives were two. The first one is to create a general workflow for print map production using open data and open source tools. And then in the end, also to design a method and a workflow that handles derived changes. We will come to talk about what these derived changes means as we go in the next slide. And then in order to achieve these objectives, I have a couple of questions. And for the first one was, how can a general workflow produce a print map, and what do we need in order to achieve this? What kind of tools are needed, and what kind of data sources could be used, and how flexible, and how can we compare in selection of these tools what is needed in order to select solely or primarily only free and open source software in order to achieve a workflow for print map production. And for the second research question was that in the end, when you use open data or OpenStreetMap data to create a database for map production, OpenStreetMap data is ever changing, and then you want to also make changes to your local database, maybe based on labeling or based on where the location of the city is in OpenStreetMap. You want to move this, but the OpenStreetMap community says, hey, you cannot move this. But in your final map that you want to produce for printing, you want to be able to change this. And in the future, when there are new changes in OpenStreetMap, you also want to be able to bring these changes into your derived changes locally, and then keep your changes that you've had initially. So the background here, of course, I mentioned earlier, where using open data solely, and then also using free software, no proprietary software. In this case, that the workflow could be implemented maybe where there is no financial, or in order to have much more the freedom, of course, where you can copy, share, distribute, and then also improve upon the workflow and then bring it back. So generally, talking about data or software all boils down to licenses, and these licenses are what describe if the data is open data or if the software is free software. So from this slide, you can see this photo I copied from the Free Software Foundation, which describes which software fall in the free category and which falls in the proprietary category. So in order to achieve the map production process, or in order to come up with a workflow, or generally when we are producing a map, a lot goes into it, from where the data comes from, if you need to edit or maintain it, if you need to do some analysis, and then the final output is generally what you see, which is the map we talk about. And then the cartographic processes begin from an unmapped area to finish the map product. And then in order to do this, I followed this cartographic process and the map design process, which in order to create a map, the map needs to have a purpose. Yeah. What is the purpose of this printed map I want to produce in the end? And in reality, is available data readily there for me to go for what kind of scale or which kind of audience am I targeting? So if I'm working on a workflow for general print map, then I need to answer some of these questions. And also, where does the data come from? How do I manage it? And then further stuff. So in order to begin, I did some requirement gathering, and of course, this was in the scope of a master's thesis and existing literature. Of course, I gathered about what kind of processes are there or what kind of researches have been done in the domain of automating print map production workflow, and also using not only in free software or open data, but in my case, when you do research, you have to look beyond just your niche and then see what works better for you. I identified some needs, and then that's how come I settled the cartographic process, the data sources, and then also about reusability of this workflow. So in order for me to achieve this, these were the requirements I defined or guarded in order to follow. So in the end, I came up with this flow chart, which is generally also built based on the cartographic process or the map production flow line. In order to achieve my map, I solely decided that free software, mentioned multiple times, the workflow should work independently. So each stage of the workflow should be able to work without interacting to the others, but they should also be able to work concurrently when they are chained together. And at the end, the map should be at a 1:25,000 scale, and the workflow should account for derived changes so that when I take the data from OpenStreetMap, modify it, when there are new changes in OpenStreetMap, I can have this data. So in order to, in order to select software for my workflow, one interesting publication from Steiniger and Hunter was methods that you could use for selecting of free and open source software. And this really helped me a lot and was the basis for the starting of which software, what tool to use for my stages. So I started with the use cases, which I gathered, which use cases were there for these tools. Evaluating criteria is the criteria that you need to decide on. In the case that we are using this for production of map in Ghana, which criteria qualifies or which criteria should we use to quantify these tools in order to select them. Evaluation, we need to define some criteria for weighing, which assign some numbers. This could come from survey or manually assigned. And some methods that could be used for this evaluation from research where this WSM, WPM, and then analytical hierarchical methods. And then categorization, it's helpful because if you categorize, then you are able to compare software in each category. It was a bit tricky in my case because some of the tools were falling in multiple categories, but I have to be as lenient as possible to fit them in one at least. So for the requirements for the second research objective, which is to account for derived changes, was a data model. This data model should be adjustable and also supports the basic elements that is we use in view the point, line, and polygons, and then also derived changes. Adopt some measure of the similarity because this is needed for reconciliation of data conflation and also handle some semantic data. Brings me now to the methods that I use for conflation or accounting for derived changes. And conflation could also come from the study of map matching or data fusion, where we have a GPS trace and we want to logically or linearly attach them to an existing road. And feature types, generally these three. And then the measure of similarity helps us to be able to account for the same object or similar objects in conflation. So it could be semantic, it could be topological or geometrical. And some approaches are also historical, and then isolating them or could be on demand, that as you use your data or as you collect, you change things as it goes. So in order to work, I needed a study area. So I decided on a smaller area, which was Ghana. But the initial was the Mansh-Nshba region. And then the field resident and the Cartographic Association were working on the project in producing a map for this region of Georgia. But as a start, it's a major species. And then I decided to process maybe a large area. And for example, you could see that when trying to work with Africa, it took 38 minutes. And then when I tried to work with Asia, it took 1 hour, 2 minutes to process this data. For Georgia, it was only 26 seconds. And then Ghana was really smaller. Here it's a table that shows the storage spaces occupied by the data that I was working with. I was only working with buildings, land use, and places. Yeah, this was not looking at the quality assurance of data, but generally the data that I got from OpenStreetMap and processing, even though I was working with a high-end computer, not less than 60 gigabytes of RAM and SSD, there was still some heads up. And Ghana is smaller and known, so I use Ghana as my test model, and then where I implemented the workflow. So in order to evaluate the software, I needed to do some shortlisting. I mentioned that some of the tools or software were conflicting in categories. These were all from evaluating of the OpenStreetMap wiki, publications, and literature, some tools that were used for each of the stages. So I settled on the model WPM for finally choosing which of these tools fit best in a category that I finally decided to use in my workflow. So you could see I have criteria 1 up to 6 here in the screenshot for these tools, and then in the end, using the model for WPM, I chose whichever ranked higher, and then selecting. So finally, the workflow was implemented using scripts, bash scripts, Python, and in the end, we started from downloading data automatically from OpenStreetMap and some DAM for hill shading. That's some transformation, put it in a schema, which is WGS84, and then there's a local projection and put it into another one. There are a lot of things happening, visualization and layout. And then finally, we have the hill shading, and it's ready to open in QGIS or whichever software that possibly support the end. And for implementation of the adjustable data model, I use the power of spatial SQL and triggers in PostGIS and Postgres to account for most of the things I implemented. And it was history-based. It only adopted one measure of similarity, which was the ID, and this ID is coming from OpenStreetMap, which could die if this feature is no longer in OpenStreetMap at one end. It was points, lines, and polygon. Worked by taking the data from an import schema in the data base. We normally modify it with a working copy, which I want to keep. But next time I bring in data from OpenStreetMap, the data comes to the public schema. It checks the map schema, which is used for producing maps. And then it checks to see if new features were modified, added, etc. And then looks into the history. So in the history is the schema where I store modified objects. And then in the end, it's checked if this feature is deleted from my own copy, then it's deleted. Or if this feature is not deleted or it's modified, then it overrides the copy that is coming from OpenStreetMap now, and then it gives me the new change object, which is going to show in my final map. So as a result, yeah, this is the selection in the end, comparison and criteria that I used for each of the various stages or categories I defined. And then for the data updates, yeah, in the end, changes were handled for both points, lines, and polygons. For points here, and only the most recent object is used. It's a bit linear, but the most recent, an object will be changed multiple times locally. But when you bring changes from OpenStreetMap, and then you need to keep what you've kept, you've modified only the most recent one in your history schema or used for handling the updates. It's accounted for. Here it's an example for lines, and the most recent one, which is the blue one, when you restore, even if it's modified in OpenStreetMap, your changes that are local are most most important than what has been changing OpenStreetMap, and also merges what is coming from OpenStreetMap as well. It's a bit two-way, some from OpenStreetMap, but yours also is also kept, and also for polygons as well. To conclude, my thesis created a general workflow for a print map at a scale of 1:25,000. A set of pairwise criteria were developed or selected to compare multiple tools, open source only. And then the most ranking one was selected. And then also a data model was created in order to handle derived changes, in order to account for future changes that are coming from both OpenStreetMap and also the local changes are also kept. And free and open source software and OpenStreetMap offers some kind of freedom, not some kind of a freedom that you can reuse, have a workflow that local authorities, like from my country, Ghana, could also benefit from, because the last time Ghana was comprehensively mapped, or map was produced was 1974. And OpenStreetMap data processing is time consuming and system intense and requires some technical skills. So if you have less technical skills and you really need to dig down in OpenStreetMap, this might be a bit intimidating, and also sometimes it's needed as well. And yeah, some recommendations were that this could produce a multi-scale output, not only in just one scale. Much could be done on the social science side that engage authorities or users about what tools they know about or what they would like to use and what is their ranking for these tools that I categorize. And then this could be used to select and also compare with just from literature. And a more advanced method could be used for the selection of a feature. And then multiple measures, not only I use ID as one measure of similarity here. Geometrical could also be used, or buffer-wise, and then the workflow could be better or more automated, but maps come out in the sense that here now it sets up everything in the database, but still human effort is required, of course, to produce a map at any time. But in the end, if map outputs could be produced a smaller scale or a small region, I mean. And then I think that was all. Just some of my references. And then thank you very much for listening. And I'm open for questions.